Good morning, my learners. You are welcome to today's lesson. Uh, Today's lesson is one of the revisions towards your exams, and you just need to listen well. The questions are not difficult; they are up to your standard. And if you have been listening to the previous presentations, you are going to even do more very well, and to even get total or score all. So today we are going to look at chemical reactions. All right. So our subtopic will be looking at chemical equations to represent reaction. And our lesson's objectives are, by the end of the lesson, you should be able to use models to represent chemical reactions, use symbols to represent chemical reactions, explain the use of a subscript in a chemical formula, explain the significance of the numbers in front of compounds, and explain that no atoms are lost or gained in a chemical reaction. All right. So, what is a chemical reaction? A chemical process or reaction in which two or more substances react to form new substances. So, I repeat, a chemical reaction is a chemical process in which two or more substances react to form new substances. So, what it means here is that a chemical reaction is basically having two substances, putting them together, and then they will give you a new substance. So, for example, if I have substance A and B, then I react them, then I get substance C, then it's a chemical reaction. All chemical reactions can be represented by equations and models. To some people, chemical equations may seem very hard to understand. Since atoms and molecules cannot be seen, they have to be imagined, and that can be quite difficult. Luckily, we have had some preparations because we have been drawing molecules since grade 7, and then you will not have much problems. Now, any time that atoms separate from each other and recombine into different combinations of atoms, we say a chemical reaction has occurred. I repeat, any time that atoms separate from each other and recombine into different combinations of atoms, we say a chemical reaction has occurred. So, if the example that I gave, if you have atom A reacting with atom B to give us atom C and D, then that's a chemical reaction. So what it means is that A plus A substance A and B, uh, the atoms in them or the bonds got broken, so they rearrange and then form different atoms that give you C and what? D. So you will see that A and B are reactants and C and D are products. So in a reaction, no atoms are lost or gained. They are simply rearranged. So what do we mean by that? So the atoms A plus B and then given as C and D, they are what? They are not lost. So the atoms before the start and the atoms after the start are just the same. They are just rearranging, but they are not lost. So a chemical substance can break apart and join together in a reaction. A chemical reaction is a process that occurs when two or more substances react to form new substances. The substances that react in a chemical reaction are called reactants. Substances are made as a result of chemical reactions are called products. The subscript number indicates the number of atoms of an element in the compound. The numbers in front of some formulae indicate the ratio in which the molecules react. No atoms are lost or gained in a chemical reaction. They are just rearranged. No atoms are lost or gained in a reaction. They are just rearranged. Okay, so what do we mean by that? All right. What it means is that if I have a chemical equation, then it's balanced. The number in front of them are what? The ratio. The ratio tell us the molecules that reacted. If there are 1, then we say, then it means one molecule reacted. Or basically we call them the mole ratio. But we will see in the following slide what this means. All right. Now, a chemical reaction, as we said, two or more substances react to give you a new substance. So reactants are the substances that react in a chemical reaction. So hydrogen and oxygen are reactants in the chemical reaction shown. So as we can see here, and products are the substances that are made as a result of a chemical reaction. Water is the product in the chemical reaction. Now see something. So you can have chemical reactions. So this is hydrogen reacting with oxygen to give you water. Hydrogen reacting with oxygen to give you water. Now, if we balance it, you will see that we have got two hydrogens here multiplied by 2, so we get 4. Now, this small 2 here is called the subscript. So the subscript is telling us the number of hydrogen atoms in a molecule. So this is the subscript. So here the subscript, oxygen, here there are 2. So it means 2 oxygen what? Molecules or atoms. So 2 oxygen atoms gives you a molecule. So here is there are 2 oxygen atoms. So that gives you a what? A molecule. So that's the subscript. Now you come here, the product gives us H2O. H2O. So this 2 here is also the subscript. Now after that, we have to balance it. So how do we balance it? We have to check. Before we balance it, we have to check on the left-hand side. On the left-hand side, we have got H2 plus O2 and then H2O. So you see that this side is 2, oxygen is 2, but this side hydrogen is 2, oxygen is 1. So to balance it, you have to make sure that oxygen on the right hand side is 2. So we have to write 2 in front of water. Now when you write 2 in front of water, then it becomes molecule. It becomes molecule. But how many molecules? 2. Or we can also say that when the product is already a water molecule, but how many? If we write 2 here, then initially it was 1 molecule. Now when we write 2, it becomes 2. So what is happening is that the 2 is affecting the whole compound. So 2 times 2 will give me 4. 2 times 1 here, the subscript here is 1. So 2 times 1 will give me 2. Okay, but initially I wanted to balance what? Oxygen. So because I've put 2 here, it's affecting 2, the whole of the 2 elements, hydrogen and oxygen. So here oxygen will be 2. So this side is 2. Now it has also affected these 2. So it is going to give me 4. Then when I come here, it's 2 initial, so I have to write 2. So it gives me 4. So then we set their balance. Now, so you see, if you look in front here, we have 2. In front here, we have 1. In front here, we have 2. So it means the mole ratio is going to be 2:1:2. Now it tells us that in this reaction, we have got 2 molecules or 2 moles of hydrogen atoms reacting with 1 molecule of oxygen now to produce what? 2 molecules of water. Now, so let's go on. So the subscript indicate the number of atoms in an element. So as I have already said, we have got the oxygen 2. In the example, there are 2 hydrogen atoms in the product. So you can see we have got 2 here in the product. The numbers in front, 2 here, 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 of some formula indicate the ratio in which the molecules react. In this example, two molecules of hydrogen react with one molecule of oxygen. So we are referring to this. So this one, two molecules of hydrogen react with oxygen to give you this. All right. So we do not write the numerical one if there is only one molecule of the element. For example, we do not write this. So you see, so oxygen, hydrogen is 2, oxygen is 2, hydrogen is 2. So here we do not write something like this. We just leave it. So when it's 1, we know that it's already 1. So we don't write anything. Okay. So let's go on. So we do not write. It's already explained here. Elements and compounds are pure substances because they consist of only one type of material. During a chemical reaction, atoms are lost or gained. Atoms are not lost or gained, as the atoms in the reactants are simply rearranged to form new groups of atoms in the product. All right, now let's try to do this activity. You remember previously when we were doing chemical reaction, we used pictures and models to represent chemical equations. So just to revise or to remind ourselves about how to uh, balance and then how to represent chemical reaction. All right. Uh, this equation, the second equation, I forgot to explain it. So now here we have got carbon dioxide giving us what carbon and oxygen. Now what it means is that carbon dioxide is the reactant giving us what carbon plus oxygen. So here you can see that the reactant is 1 and then it will break down to give us what? Carbon and oxygen. So when we have something like this, it is called what? Decomposition reaction. And decomposition reaction simply means you have a compound that breaks down into 2 or more. So here we have got 2 carbon dioxide breaking to give us carbon and oxygen. Now the opposite of this will give us carbon dioxide, you remember. So what I'm simply saying is that if now the reactant is carbon plus oxygen, we get carbon dioxide. All right. So let's then continue. So this is an activity I want you to do. So just ignore task 1. This one, if you were in the main classroom, you could have developed it. But here, you can develop it on your own by using clay or plasticine or any other object that can assist you to mold. Then after you can change the colors. All right, and then you can arrange them like this. So now task 2, you have to look at these pictures and models and then name the reactants and products in the chemical reaction. Then to explain how the atoms in the reactants are arranged to form the product. And 3, write a formula to represent the chemical reaction between carbon and oxygen that forms carbon dioxide. All right. So I will be waiting if you have any question or you send in your answer so that we will I will correct you so that we can proceed. Okay. Now, so if you did oh, do your activity, uh, your answer should be something like this. Your answer should be something like this. So we have reactants giving us carbon dioxide and oxygen. So you can see from the equation that the reactants will be carbon and oxygen. Then our product will be what? Carbon dioxide. Then number 2 will be one carbon atom react with what? 2 oxygen atoms to form what? Carbon dioxide. And then the equation here, we're supposed to get carbon plus oxygen to give us carbon dioxide. Now again, if we are going to check, we can to the subscript. So here the carbon is 1, but we don't write it. If it is 1, is we just leave it like the way it is. Then oxygen. Now here it means the subscript 2. Now what does the subscript tell us? It tells us that we have got 2 oxygen atoms. Then we have got what? Carbon dioxide. So the carbon dioxide, in the carbon dioxide, we have got 1 subscript for carbon and 2 for what? Oxygen. Now let's see whether the equation is balanced. So here we have 1 for carbon. On the right hand side, we have 1 for carbon. Then 2 for oxygen on the right hand side and 2 for oxygen on the left hand side. So you see that it's balanced. So if you have done well, if you have done well, you should get something like this. All right, now let's look at the assessment. So if a molecule has a subscript of 3, what does that tell you? What is the ratio of hydrogen molecule sorry, hydrogen molecules to oxygen molecules in water? The chemical equation for zinc oxide is ZNO. How many different substances are there? So just ignore the 2 and then you just submit your answers. Is this statement true or false? The subscript number indicates the number of compounds found in the formula. I will be waiting for your answers in the chat room for moderation and checking. All right. Now we have come. So if we have come to the end of the lesson, but before that we have to do the correction. And after, you are welcome to ask any questions that you can ask in relation to the exams for tomorrow. If a molecule has, so these are the corrections. If a molecule has subscript of 3, what does that tell you? What does that tell you? And what is the ratio of hydrogen molecules to oxygen molecules in water? Then the answers are A, the element has 3 atoms, and B, the ratio is what? 2 is to 1. 2 is to 1. So if you look at the molecule is H2O. Water molecule is H2O. All right. Now, if we look at question 2, the chemical equation for zinc is ZO. So how many different reactants are there? So we have got 2 zinc and oxygen. So if you ignore this, 2 is going to be zinc and oxygen. But if the 2 is there, then we can simply say 2 zinc and 2 oxygen, 2 zinc and oxygen. Then is this statement true or false? The subscript number indicates the number of carbon compounds found in the formula. And the answer is false. The subscript number indicates the number of atoms of an element found in the formula. All right. I'm waiting for your questions so that you can't ask for clarification. And learners, the questions are just straightforward. So if you have been listening and attending previous lessons, you're going to be fine. So today, we are not going to do Kahoot. We will do it next time. Good luck and enjoy your next lesson, and see you tomorrow when you finish writing your exam.